Hello, welcome to another coding challenge video. In this coding challenge, I'm going to look at something called lexicographic ordering and look at an algorithm for solving lexicographic, which for some reason I can't say, but you can say lexical for short, so I'm going to say lexical ordering, which is kind of like alphabetical ordering. And we're going to look at how that works, make a little algorithm that solves it. You might have some creative ideas about how to visualize it or make something out of it. And then I'm going to apply it to the traveling salesperson problem to look at how we can look at every possible path through a set of cities. Okay, so let's just talk for a second about what lexical, thank you very much, ordering is, and I'm going to come do that over here. So let's just say, I kind of did this before, but let's just say I have the letters A, B, and C. So these are actually sorted in alphabetical order, right? A comes before B, B comes before C. But what if I want to know the next ordering of these that's also the next order in alphabetical order? Like I could say, like, here's another order, C, B, A, or here's another order, B, A, C, but neither of these are the next order in alphabetical order. Now, I could tell you that the next ordering in alphabetical order is A, C, B, right? Because A should come first. Well, B already came second. The only other possibility is C, and then the only thing left is B. And then we could think, okay, well, I tried all the A possibilities, so the next in alphabetical order. And by the way, lexical order and alphabetical order are very similar concepts. There's a sort of subtle distinction, which has to do with how numbers or dates are kind of treated in the way that you might sort things in kind of the computer way. This is, by the way, my version of the computer way. But I'll let you read about that in this page that I'm going to show you that has more information. So I could say B, and then what would be next in alphabetical order would be A, and then all I have left is C. And so B is next, and then C, and then A, and then C, then A, then B, then C, then B, then A. So I could do this rather easily myself, but you know, if I have A, B, C, D, E, F, G, H, I, it's going to be a little bit harder, although not that much harder, because honestly, it's just going to be A, B, C, D, E, F, G, I, then H. Right, you can sort of imagine, and there's this swapping. So what we need is an algorithm to do this for us and then print out every single possible ordering. Because what I'm ultimately going to do with this is actually use these as indices into an array that has different cities in it. So, you know, Baltimore, New York, London, I don't know, I shouldn't be so US, Europe-centric. Everybody in the comments, give me some better cities to use in my next example. But so you could imagine this is going to be 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, 2, I don't know if I'm getting this right, 2, 0, 1, 2, 1, 0, something like that. So hopefully I got that right, but this is what I want to do, and I want to try the cities in all of these orders. So let's go back over here, and I found this wonderful page on the subway this morning that I read in my Google search, which was a Quora post that says, how would you explain an algorithm generates permutations using lexicographic ordering? So the wonderful thing about this answer by Michael Foracek, which I'm sure I'm not pronouncing correctly, somebody will have to, oh, people are giving me great cities, Kuala Lumpur, Rio, Coventry, UK. So let's be international coding rainbow here in this thing that I'm doing on YouTube. But so for the impatient, here's the actual algorithm. So what I'm actually going to do in this video is just kind of read through this algorithm and sort of talk you through it and implement it. And I would suggest to you that if you want to find more about it, you can kind of read further down this page where the author provides an example scenario of an example order, how the algorithm plays out with that example, and then also derives this algorithm. But I'm going to kind of leave that aside as kind of, and I just want to kind of like, I think you might have an intuitive or kind of sense of how it works just by implementing it. So first, let's get ourselves set up to do this. What I want is to have an array. I'm going to start with an array. And I'm going to call it vals. Yeah, that's fine. And I'm going to have it be 0, 1, 2. We're just going to start with 3 numbers so that we can see that it works. And what I want to do now in draw is, first I want to, what happens if I do console.log vals? So let's just look at that. And run this, we can say, okay, so that's good. I'm seeing here in the console the current order of the array. So I want to see it as I do each permutation one at a time. So if I go back to this explanation, first, and let me zoom in on this so you can see it better. Find the largest x such that p index x is less than p index x plus 1. Okay, so what does that mean? Often we think of I as the index, not X, but what we're looking for is where is there something in the array, the highest, the element closest to the end of the array where its number is less than the last number. So, and intuitively right now we can say, like, which one is that? It's this one, right? And honestly, if this were the array, 3, 4, 5, 6, 7, it would be this one, right? Right now, the last element of the array, that is less than the one next to it, is, when it's in order, is always the second to last one. But we should write an algorithm to make sure of that. So the first thing I want to say is largest I, I'm going to assume it's 0. And then I'm going to loop through the entire array. And what I want to do is say, okay, if val's index I is less than val's I plus 1, then largest I equals I. And I can't go to the very end, right? So I want to find what is the largest. And you know what I really need to do? I want to start with this as -1. Because I want to start with an invalid index. Because if I don't find anything, that's going to be important. If we go back to this algorithm, if there is no such x, that means we finished. So what I wanted to add here is say, right here, after I do this loop, if largest I equals -1, no loop, console.log finished. No loop is a function in P5 that just stops this animation loop from going. Okay, so we can see that here. I've kind of implemented, I've implemented step 1 of the algorithm. And let me just, in the code here, just add a link to this article that I'm using, just so I don't forget to do that later. Okay, now, find the largest y, or you might think sort of in this case, I'm going to use j, because I'm used to using I and j as index values. Find the largest y such that the index x that I just found, that's the largest one, is less than y. So let's think about that, right? So let's say, I think I might need a diagram for this. Oh yeah, I have my, so let's say we have a bunch of numbers, 0, 1, 2, 5, 6, 8, 4, 3, right? Let's find that largest x, which I'm calling largest I, such that the value in the array, the index is less than the one after it, which would be here. So 0, 1, 2, 3, 4. So this is 4. Now, so what's the next step? Whoops. The next step is find the largest y such that p of x is less than p of y. Not of, p index x. So I now need to find whichever one in here is actually less than this number 6. And that's actually here, right? This one is the largest one that's less than the number 6. So, so if we come back to the algorithm and I implement that, what I want to do is I need to go through, and I'm going to use j. I'm going to go through the array again, and I'm going to say largest j equals -1. So what I want to do is here, the largest y such that p of x is less than p of y, p index x. So if val's index j is less than val's index largest I, which was x, then largest j equals j. So now I have largest I and largest j. I have both of those. And I don't think I need length -1 here because I can check all of them. We'll find out. Now, swap p index x and p index y. Now, you might have come to this video without watching the previous one I made on traveling salesperson. But in that video, I look at a quick little algorithm for swapping two elements of an array. And here's the function that does that, right? I have a function called swap. I receive an array. I receive an I and a j. I save the value that's at a index I. I put the value that's at j in I. And I put the value that was at I in j. So now all I need to do is say swap largest I, largest j. right? And then reverse. Oh boy. So this is kind of a funny thing, but what I also now need to do is reverse everything that's between x plus 1 to n. Now, how do I do that? This is going to be a little bit goofy. I'm back from thinking about and talking with the chat about how to do this last step, reverse. So, but first let's see. We did steps 2 and steps 3. Let me at least add some. This is step 2, and this is now step 3. And what I want to do for step 4, and let me write this out, is reverse from x, largest I plus 1 to the end, right? So what I want to do is reverse everything that's from largest I plus 1 to the end of the array. Okay, so one thing that I could do, I think a way that I could do this, thank you to the chat again, is I could say, I'm just going to call this end array, and I'm going to say vals.splice. Now, if you remember, I don't know what you remember this from, but if I go back to the my array documentation page, I'm going to look at splice, not slice, splice. What splice does is it takes a start index and then an amount of things you want to delete out of the array. But not only am I deleting them out of the array, I'm actually getting them as a separate array. So what I can actually do is say vals.splice from largest I, and then how many things do I want? I want, I think that the length is the array's length minus largest I. Is that right? Like if the array has 5 things in it, and my largest I is that's 0, 1, 2, 3, 4 is at 2. 5 minus index 2, minus 1, right? Vals dot length minus largest I minus 1, I believe is right. That's the length that I want to splice out. Let's confirm that. Let's debug this to be sure. 5, 6, 7, 8, 9. And what I want to do is I want to say a.splice. What happens, by the way, if I just give it the index? Like 2. So 2 should be 0, 1, 2, 5, 6 at 7. So I don't even need that last argument. Splice will do it for me. I don't need to calculate the length. Brilliant. Then I could say end array dot reverse. Now, does that actually change the array itself? A dot reverse. Whoa. Oh, A is that. Start over. Let's work with that. A is this array. Now B is A.splice 2. So now I have that as B. Maybe I need to make this bigger so you can see this. Now I want to try to reverse that. B.reverse. But what is the B? It does actually reverse the array itself, not just create a new array that's returned back. So now all I need to do is say end array reverse. And then what I can do is say vals.append. I can just put it back. So what I did is I took the end of the array off, I reversed it, and then I put the end of the array back on, which is essentially doing exactly this piece of the algorithm. Reverse x plus 1. And did I add the plus 1 in there? I think I did. Plus 1. OK. So I need to add that plus 1 in there. So this is done. I've done step 1, step 2, step 3, and step 4. Now what we should be able to do is look at those values. And, whoops. And I should be able to run this again and sort of see what happens. Whoops. Vals.append is not a function. Hey, append is not an array. Oh, push must be push. There's no append function. Must be push. You must be allowed to push a full array, right? The elements to add to the end of the array, and you probably can push another array, right? I'm pretty sure you can. So let's try push and see if this works. And okay, this is too many things for me to see. Let's just do it with, let's run a quick little test here. And oh, no. So how do I concat? Maybe it's concat, because you can see what it did is actually just push the full array on there, which is not what I want to do. So let's go back and fix that. It would be nice if I knew what I was doing, wouldn't it? I guess you're seeing the process of how things are figured out by people who don't know what they're doing. Nope. Vals.concat. Let's look at concat. We're getting close. concat. The concat method returns a new array. So I've got to set it back equal to itself. There's probably some sort of slightly more efficient way of doing this, but this will do just fine for us right now. There we go. Up. All right, so I'm getting something, but I'm missing something. So I have got to, I could use push.apply, but I'm trying to, so there's some fancy JavaScript ways I could do this, but I'm gonna try to kind of get around those ways. So something is going wrong here. So what I want to do is I actually want to take this, I want to actually just say no loop. And I want to be able to look at this running one at a time. So a way that I can in P5, by the way, is run each draw loop one at a time. One, as I can just say redraw. I thought I could at least. Oh, do I have no loop in here? Let's take that out. Do I have console.log? Maybe I took out the console.log. Whoops. Console.log vals. Yeah. Okay, so I'm getting the same array each time, and maybe the call to swap is incorrect, as someone in the chat is saying. So let me look this up. I'm now in a debugging portion, which maybe I'll edit. Maybe this should get edited out, but I guess it's staying in. Swap. So let's look and see what we're getting, if we're getting values that make sense. So the first thing I want to look at is largest I. And then I want to look at largest j, which is probably, I'm guessing I did something wrong there. And then I want to look, so let's just look at that for a second. So the largest I is 1, which makes sense. That's the largest index where it is less than 2. Now the largest j is, if we look at the algorithm, is the largest j such that, I have my code is wrong. Look at this. This should be largest I is less than j. If we look at that algorithm again, that makes total sense, that I'm looking for the element of the array furthest along that's actually greater than the one that I just found. So that should fix things up here. And then if I say redraw, okay, so that's a little bit better. I've made an improvement here that I'm finding. Let me refresh this. That the largest is 1, and then the largest j, which is 2, which is greater than what I just found, is the last element. That's correct. And I've got a terrible error here. Bad, sad little bug. I just had a brain malfunction when I wrote this swap function. It's like swap, largest I and largest j, but swap it with what? And the chat just pointed it out to me. The way that I wrote this function is I've got to say, here's the array that I want you to swap these elements in. So I've got to actually put that array in there, which is vals. So let's redraw, and we can see, there we go. Now we can see the order is happening. So I can take out some of the console logs. I can put in no loop back here, and I can take no loop out here, and I can run this, and we should see, there we go. 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, 2, 0, 1, 2, 1, 0. We got it. Yay. Now, let's be a little fancier here, and let's put something in in the window. I'm going to say text size 64. I want to create a string, and I want to loop through the current values. And I want to say s plus equals I, and then I want to say fill 255, and I want to say text s. So I just want to draw the text at like 20 and height divided by 2. So I just want to see, and did I put that? I want to see, oh, I guess it just happened so fast. Oh, not of I want vals index I. There we go. I want to see it do all the possibilities there. So I want to be able to see that happening in the window. And now we can try 3, 4, 5, 6, 7, 8, 9 to see how this goes. And we can see, here we go. I am now looking at, it's almost like I'm counting down backwards in this weird way. This is now every single possible permutation of 10 numbers. Now, you'll notice this is going to take a really long time to finish. It's running at 60 frames per second, so it's doing 60 possibilities every second. And how many possibilities are there? 10 factorial, which is this particular number, which is like 3,628,800. So I could let this run, but I'm going to stop this particular video, and you could sort of calculate how long is it going to take. How long is it going to take if you go to 11? This video about lexical ordering goes to 11. And except it doesn't, because it actually just goes to 10. So, what might be some interesting creative ways you could sort of visualize these permutations? What might be another scenario where you use all these permutations? And what I'm going to do in the next video is I'm going to use this to try every single possible permutation of the order of cities in the traveling salesperson problem. And once I do that, I'm going to look at an evolution. After that, I'll look at an evolutionary strategy for solving the traveling salesperson problem. Okay, thanks very much. See you in the next video.